Today we're going to talk about seasons. Our learning target for today is I will explain how the tilt of Earth and distribution of sunlight causes seasons. First, let's build on our background knowledge. Remember that the Earth spins on its axis every 24 hours, and we call that rotating. A day is when the side of Earth is facing the sun. And night is when our side of Earth is turned away from the sun. 24 hours equals 1 day. You might have heard the saying that the sun rises in the east and sets in the west. This is because of Earth's rotation on its axis. The picture that you see here is not representing true east and true west, but it's a good representation of the sun rising in the east and setting in the west. The Earth revolves or moves around the sun, and 365 days is equal to 1 year. So, what causes seasons? Seasons are the result of the tilt of Earth's axis and its elliptical revolution around the sun. So the tilt of Earth's axis and the revolution around the sun is what causes seasons. The Earth is tilted 23.5 degrees. So this isn't a temperature. These are things you would use a protractor for, angles. Okay, so this is just a representation of the Earth revolving around the sun. Notice that the Earth stays tilted, right? It moves, and different parts of the northern hemisphere are tilted toward the sun at different parts or times of the seasons. So the number of daylight hours is greater for the hemisphere that is tilted toward the sun. We live in the northern hemisphere, which is above the equator. So if you look at this graphic, you'll see the angle at which daylight is being received, and then how long the daylight hours are for that portion. There are some places that receive 24 hours of daylight and some places that receive no daylight at all during parts of the year. Summer is warmer than winter because the sun's rays hit Earth at a more direct angle. Therefore, days are longer. During winter, the sun's rays hit Earth at an extreme angle. Therefore, days are shorter. If you look at this graphic, here's the northern hemisphere. The sun's rays are still coming in straight, but instead of hitting directly at the northern hemisphere, it's hitting at an angle. Therefore, our days are shorter. You might be noticing this already. It gets darker sooner, and it stays darker longer in the morning, as opposed to when it was summer. This just shows the northern hemisphere when it is tilted toward the sun, receiving direct light, therefore our days are longer. And this side shows the northern hemisphere tilted away from the sun, where it's receiving sunlight at an angle, therefore days are shorter. Well, what if Earth wasn't tilted? If Earth does not have a tilt, then our climate and our seasons would be affected. The amount of sunlight striking each region would be the same all year. Therefore, the climate in the region would remain the same. Similarly, for seasons, we would be receiving the same amount of sunlight equally in every area. Therefore, there will be no change in seasons. Because of seasons, we have something called solstice. Solstice is when the tilt of the Earth's axis is at its extreme. It's either tilted the farthest away from the sun or the closest to the sun. When it's tilted the farthest away from the sun, we call that winter solstice, and that's the shortest day. And that day occurs December 21st every year. When Earth is tilted on its axis and it's closest to the sun, we call that summer solstice, and that's going to give us the longest day, and that happens every June 21st. So our solstices are our days when the tilt of Earth's axis is at its extreme. So this graphic right here, it shows the distribution of light during summer and winter solstice. Notice that in winter solstice, it's mostly at the bottom of the Earth, and in summer solstice, it's hitting the top of the Earth, or the northern hemisphere, whereas the winter solstice is mostly hitting the southern hemisphere. Along with solstices, we also have something called equinox. That is when the sun is directly over the Earth's equator, and it's just like it sounds, equal day and night hours. We have spring equinox, which occurs every March 21st, and we also have fall equinox, which occurs September 22nd. Okay, so here's a graphic showing what that sun distribution looks like during equinox. Remember, we live in the northern hemisphere, and the southern hemisphere, which is below the equator, is going to experience the opposite season. So when the northern hemisphere experiences autumn, the southern hemisphere is going to experience spring. When the northern hemisphere experiences winter, then the southern hemisphere will experience summer. When the northern hemisphere experiences spring, then the southern hemisphere will experience autumn. And lastly, when the northern hemisphere is experiencing summer, the southern hemisphere is experiencing winter. And we can see that in the graphic as you watch the snow start in the northern hemisphere and kind of move down into the southern hemisphere as the seasons change. Here's another graphic. It's labeled for the northern hemisphere, showing the move from the equinox to the winter solstice to the spring equinox to the summer solstice. Again, notice that Earth is continuously tilted. Remember, Earth is tilted on its axis, it's rotating on that axis, and it's making an elliptical revolution around the sun. And this is why we have seasons. Make sure that you answer your essential question. Explain the cause of seasons. You should be using your notes to answer this question so that you know that you have the correct information.